Hi everyone, welcome back to a new video. In this video, we are going to talk about any, which is an interface constraint in Golang. So let's get started. First of all, what is any? So any is nothing but an alias for an empty interface. This is how you write it. Now, what is an empty interface? Let's understand that through code. So I'll just create a main.go. Package main. Let's import fmt. Most probably I'll need it. Yeah. So what is an empty interface first of all? Before that, what is an interface? If I have to create an interface called animal, and let's say it has a method called walk. Now, if I create a dog struct, yes, thank you for the recommendation. And let's say random thing, name, and let's say this dog implements this walk method. Now, what does that mean? An interface is just a contract that says that, okay, if your type satisfies or implements this walk method, then it is an animal, right? So dog, since dog has this walk method, it is an animal. Now think of an empty interface. Type, not struct interface. Now, what did we say in this case? That for a dog to be an animal, we need it to implement walk interface. But for a dog to be an empty interface, what do we need to implement? Nothing, right? Because it is empty. Hence, dog automatically implements interface, empty interface. In fact, a variable x of type int, it has no method, but it also has no method. So it also implements this empty interface. A variable y, which is string, also implements it. A variable x that is a channel, that also implements it. Okay, we declared it. XW, that also implements it. So that is what we mean when we say empty interface. It means that any type is valid. So if we see this list, all the types in Golang, all these types in Golang implement this empty interface. So in place of any, you can use any of these types. Booleans are there, int, and then floating numbers. In fact, functions are there, channels are there, pointers are there. So every type in Golang satisfies an empty interface. It is a interface constraint, but it is sort of not a constraint because it says anything is allowed. Let me make it more clear using code. So let's get rid of all of this. I think now we know what an empty interface is. Let's create a variable x, which is of type any. And any is nothing, like I said, an alias for empty interface. Let's do any, and let me show you what any is. So it is nothing but an empty interface. Now I can do x equal to 1, which is an int. I can do x is equals to hi, which is a string. We could do x is equals to 1.2, which is a float. And all of them will work fine. Let's also print them. Is and let's say type is, yeah, this is giving the right suggestion. Oh, sorry. So if I now try to print this, as in run this command, oh, I am stupid. Should be printf. Sorry for that. Uh, let's do it now. Yes, so x can be an int, it can be a string, it can be a float, anything. There are a few more interesting things that we can do with any. So let us say we can create a mixed slice. Yeah, it gave me the perfect one. Yeah, so this is a slice of any type, so we can have all the types over here. And if we try to run this, it works perfectly fine. Values are coming perfectly fine. So that is the idea with any. It is literally any type. And where would you want to use it? You would want to use it in functions where you do not know what type of value will be coming in future to that particular function. If I show you some examples, actually Go also uses any in their internal functions. So this print that you see does use any. So if we go to the implementation part, you can see it takes type any in a variadic form. Why? Obviously, because we do not know what are we going to print in future. We can print an integer, we can print an, in this case, we did a string, we can do a float, we can do anything, right? That's why we use any over here. There's one more. If you check JSON.unmarshal, because we do not know what type we would unmarshal our data to. So there also we use any. So if I have to create this variable, let's say result, yeah, let's say any, or let's say actually slice of any, or maybe better, we should make it a map, and then any. What I'm trying to do is I'll create this string. Perfect. And we can print it. Great. So I'm going to unmarshal this string into my result that I made right now, and I'm going to print it. So let's try it out. And it works fine. So again, since we do not know what value are we going to print, we will keep it as an empty interface. Similarly, we do not know what we would want to unmarshal our JSON into. So we will keep that as well as an empty interface. So these are the use cases of empty interfaces. Obviously, you should not be using it in this particular way. This is not good because of type safety and also because of the memory it is going to take. Because if this were to be something like variable y integer is equals to 1, let me just print it out so it doesn't give an error. Then in this case, this y is just an integer, so it gets stored in the memory, and it gets stored in the stack memory. It is much faster to access, but in this case it is of type any. So what happens in this case is we actually box this value into a struct. So for every empty interface that you create, it is boxed into a struct and then it is saved to the heap. So two problems with this. Firstly, we are storing it in heap, so it is much slower to access and it takes more memory because we are boxing it into a struct and then storing it. So only use this any or the empty interface in cases where we absolutely need it because we do not know what type of value will be coming to that particular function. So that is it about any or about empty interfaces. I hope this video helped you, and I hope you can find some use cases for any in your code base. If you are interested in watching more videos about Golang, then you can check out the channel. In either case, thank you for watching this one, and I'll see you in the next one.